So this is the first classwork for Statistics 2, MH204. We're going to go through using the MN rule, using permutations, and using combinations, all as ways of assessing probability. So the MN rule is the most basic way to think about how things can be combined. It basically says if we have 10 choices here and 5 choices here, the total number of choices is that we could have taken any of these 10 times any of these 5, means 10 times 5 equals 50. That's all the MN rule really does. So when we're given something from the MN rule in WebAssign, the phrasing looks like it does if you look at this classwork PDF that I put up to go along with this. Basically, it says something like, use the MN rule to find the number of items. There are 2 groups of distinctly different items, 20 in the first group and 12 in the second group. If you select one item from each group, how many pairs can you form? 20 in the first, 12 in the second, how many pairs can you form? So the number of pairs that I can form using the MN rule, MN equals 20 times 12. If I were to put that in my calculator, 12 times 20 would give me 240. So the final answer to my question would be 240. For question 2, it says 3 dice are tossed. How many possible outcomes are in the sample space? It's important to note here that there's a difference between 6, 5, 6 and 6, 6, 5. So the sample space is based out of a first number, a second number, and a third number. There's 6 possibilities for the first number. There's 6 possibilities for the second number. There's 6 possibilities for the third number. If I'd been told were 3 different types of dice, like one had 6 sides, one had 10 sides, one had 20 sides, I'd do 6 times 10 times 20. If they just say dice, it's assumed they're standard 6-sided die. 6 times 6 gives me 36, times 6 gives me 216. 6 cubed is 216, which is the total number of different outcomes I would have when I toss 3 dice. That MN rule is the way that the first few questions on the homework are phrased. Then we get into permutations and combinations. Permutations and combinations are ways of using this information. Specifically, a factorial, or n exclamation point, equals n times n minus 1 times n minus 2 on down to 1. So if, for instance, I had 8 factorial, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. These factorial make up combinations and permutations. A combination is a way of saying if I have n items and I want to choose r of them, here's the number of different ways that I can do that. I do it by taking n factorial over n minus r factorial times r factorial. This last r factorial isn't there when we do the permutation formula. So these 2 formulas look the same except for this extra r factorial. What that means is when we divide them out in r factorial here from combinations, let me make sure that I'm doing that right. Sorry, I recorded this and put this on. Yeah, in combinations. We're dividing it out in combinations, which means we'll get less answers for combinations because they don't care about the order that things happen in. As opposed to permutations, we don't divide out the r factorial because we do care the order that things happen in. So if, for instance, we're looking at these 2 problems, this problem is a permutation that says from 8 items, we're going to choose 3, and we do care about the order that they occur in. Let's say it's a situation where we have 8 students in a class and we need to elect a president, a vice president, and a treasurer. In that case, it's different if we have one person as president, the other as vice president, one of them, and the other way we don't. As opposed to a combination would be something like, we're going to choose 3 students to be the student council for this 8-person class. In that case, it doesn't matter which order they're chosen in. If they're chosen for a spot in the student council, it's the same. So when you do a combination like that, that's why this r factorial goes on bottom. It gets divided out. It's saying these are times where things are double counted. Let's divide out the times that are double counted that are really the same outcome. That's the difference between a permutation and combination. What you really need to know is how to do it in this calculator or whatever calculator you're using for the class. The way that you do it, for a permutation, you take the top number, you write it in your calculator. For me, I then would, on this calculator, press the math button. I would go over to the far right column labeled PRB, and I would go down to the second thing listed, NPR. After I press enter, it shows up in my screen as NPR. I can then put the final number 3, and the calculator will give me an answer. When I do that, I get 336. So the permutation, 8 in the group, we're going to choose 3 of them, goes as 8 NPR 3, which gives me an answer of 336. What the calculator really did there was apply this formula. It said NPR of 8 and 3 would mean that I do 8 factorial, which I've written out here, divided by n minus r factorial, or in this case, 8 minus 3 factorial. 8 minus 3 factorial is really 5 factorial, which means it would get rid of this 5 times 4 times 3 times 2 times 1, because it would be on the same on top and bottom. That would leave me with 8 times 7 times 6. 8 times 7 times 6 gets me to this 336. When I check it in my calculator, 8 times 7 times 6 also gives me 336, the same way the NPR did. So what that tells me is that basically I can use my calculator to answer questions like these. If I can get it into a form like this that my calculator understands, I'll be able to find how many combinations or permutations exist in a certain situation. Trying this one, I would put it in as 15 NPR 5. When I do that, 15, math button, over to the PRB, second one, NPR 5. It gives me a huge number, specifically 360360. So another way to look at this, when we got this down to 8 times 7 times 6, really we're going to fill 3 positions from those 8 people. When we first choose the first person, there's 8 possible choices for that first position. Now that that position is filled, there's only 7 people left to choose from, which means when we go to fill the second position, we have 7 possibilities. When we go to fill the third position, these 2 people are no longer in the population to be chosen because they're already locked into these positions, which means there's only 6 left to choose from. When we do this one, if I wanted to write out everything that's happening, it'd really be, since we're choosing 5 people, we have 15 choices the first time, 14 the next time, 13 the next time, 12 the next time, 11 the next time. 1, 2, 3, 4, 5. If I multiplied all this out, I should get what we get here. Doing problem number 5 is a combination. Again, the difference between combination and permutation, I don't care about what order I get people in. So here, 8, 7, 6, if this was John, Jane, and Jen, it wouldn't be any different than if I got Jen, Jane, and John. I need to divide that out by doing this r factorial on bottom. But really the only difference for you when you put these in your calculator is when you go to do the menu, you're going to put in 8, and then when you choose from the math menu, instead of going over to PRB and selecting the second option, you'll select the third option, NCR. I put in NCR 3, 8 NCR 3 gives me 56. Notice that's significantly less than what I got above. Really, it's this divided by 6 to get back to here, because that's how many different ways I could rearrange things that would really be the same student council I was for. For question 6, same idea. I put it into my calculator as 15 NCR 5. This time, if I do 15 math, move over to PRB, NCR 5, it gives me 3,003. Noticeably less than 360,360. That's because I'm dividing by r factorial, in this case 5 factorial. When I divide that whole thing by 5 factorial, I get down to this, which are the new times that you would get completely new groups, not just based on reordered new groups. So again, the key distinction between permutation and combination: order does matter. I care about the order people are selected. Order does not matter. I don't care about the order things are selected. In some of the WebAssign problems, they'll explicitly tell you order doesn't matter or order does matter. In other problems, you have to kind of think, in this situation, would I care the order things were chosen or would I not care? So the word problems can get a little tricky, but really that's the question you're asking yourselves. When you get one of these combinations or permutations, do I care about order? If you do care about order, do it as a permutation. If not, you do it as a combination. So here, order does not matter. When order does not matter, I do it as a combination. Pick 3 people from 10 people. Well, that means I'm going to do 10 that I start with. Then I'm going to NCR from them. I'm going to choose groups of 3. When I put that into my calculator, 10, math, PRB, NCR 3, I get 120. There's 120 different groups of 3 that I could choose from 10 people. If instead I'm doing it where order does matter, then I'm setting it up the same way. 10 is the number that I start with, and PR, because I care about the order, 3 is how large my group size is. If I put it in as 10, go over to PRB, select the second option, NPR 3, I get 720 different ways that I could create a group of 3 if order does matter from my 10. In number 9, it asks, how many orders can I schedule 5 classes? So I think I ask it a little longer in the PDF version, where I basically say, if you have 5 classes that matter, how many different ways can you schedule those classes? In this case, my order definitely matters. So if I'm asking how many ways can I schedule my 5 classes, what I'm really doing is I'm taking from 5 classes, selecting in a way that order matters 5 of those classes. If I put that into my calculator, 5 NPR 5, it gives me an answer of 120 different ways that I can do it. Note that if I did this as NCR, I would get exactly 1. It would basically be asking, if I'm going to take these 5 classes, how many different ways can I get a group of 5 classes if I don't care what order I take them in? Well, you know you're taking those 5, there's only one way to do it. So here, the fact that order matters is really what turns it into a problem. There's one like this on the homework where it doesn't look like it gives you enough information, but it's basically the same general idea. If we're worried about how many orders are happening, it's how many orders if I select all from a group of a set number. So all 5 classes, select all of them, but how many orders can it happen in is what this is doing. You also will see sprinkled in there some word problems that actually go back to the MN rule. In this case, I'm given 3 different parts of outfits that I own. I own 15 shirts, 12 pairs of pants, 6 pairs of shoes. How many outfits can I make from that? In this case, they're each independent decisions. I'm selecting 1 of 15 from the shirts, 1 of 12 from the pants, 1 of 6 from the shoes to create a unique outfit. When I do that using MN rule, I'm really doing 15 times 12 times 6. When I put that into my calculator, 15 times 12 times 6, I get an answer of 1,080. So these 3 counting rules are really being applied here. Hopefully it's straightforward. If you run into ones where you're not sure what they're asking, definitely use the Ask Your Teacher feature in WebAssign. And don't be afraid to email me otherwise if there's anything I can do to help.